Right now, tonight, somewhere over an ocean or a military installation or a quiet stretch of empty sky, a sensor is picking up something nobody can immediately explain. Not a hoax, not a hallucination, an actual recorded signal, a blip on a radar screen, a shape in an infrared camera that does not match anything in the database of known aircraft. This happens more often than most people realize, and for decades, the people who experienced it, mostly trained military pilots with careers to protect, simply stayed quiet because saying the words unidentified flying object out loud was, professionally speaking, a fast way to get laughed out of a room. That has changed. In the last few years, governments have opened files, physicists have started taking the question seriously in public, and one of the most respected and famously skeptical voices in modern physics has spent real airtime walking through exactly what the evidence does and does not show. Her name is Sabine Hossenfelder, and she is not the kind of scientist who chases headlines. She built her reputation criticizing her own field for chasing pretty ideas instead of provable ones. So when she sits down to talk about UFOs and the deeper question hiding underneath them, the question of why, in a universe old enough and vast enough to be teeming with other civilizations, we appear to be completely alone. It is worth paying close attention to exactly what she says and exactly what she does not. Because the honest answer sitting underneath this entire topic is stranger, more layered, and considerably more interesting than either the true believers or the total dismissers usually admit. Stick with this one all the way through, because the way the story actually resolves, or more accurately, the way it currently refuses to resolve, is not what either side of this argument usually expects. To understand where this conversation actually starts, you have to go back to a lunch in the summer of 1950 at Los Alamos National Laboratory in New Mexico, the same desert research facility where the atomic bomb had been built a few years earlier. A handful of physicists, including Enrico Fermi, one of the most brilliant minds of the 20th century, were walking to the cafeteria, joking about a recent wave of newspaper cartoons showing flying saucers. The joke faded into ordinary conversation, and then, seemingly out of nowhere, in the middle of an unrelated discussion, Fermi asked a simple question that nobody at the table could immediately answer. Where is everybody? He was not asking about aliens showing up at the cafeteria. He was asking something much larger and much colder, a question about scale. The galaxy we live in is roughly 6 billion years old and contains hundreds of billions of stars, a huge number of which are older than our own sun, if even a small fraction of those stars have Earth-like planets, and if even a tiny fraction of those planets developed intelligent life, and if even a fraction of those civilizations eventually developed the ability to travel or communicate across interstellar distances, then simple arithmetic says the galaxy should already be full of noise, full of signals, full of evidence. Even a civilization traveling at a slow, unglamorous 1% of the speed of light could, in principle, cross and colonize the entire galaxy in something on the order of a few million years, a blink of an eye compared to the galaxy's total age. Given enough time, the silence should not exist. And yet it does. That contradiction between how likely intelligent life should statistically be and how completely absent any confirmed evidence of it actually is became known as the Fermi Paradox, and it has haunted physics, astronomy, and quiet philosophical conversations at dinner tables ever since. 11 years later, in 1961, an astronomer named Frank Drake tried to put actual numbers on that question, presenting what became known as the Drake equation at a research facility in Green Bank, West Virginia. The equation itself is not complicated in structure. It multiplies together a chain of estimates, the rate at which stars form, the fraction of those stars with planets, the fraction of those planets that could support life, the fraction where life actually develops, the fraction where that life becomes intelligent, the fraction that develops detectable technology, and finally, the average length of time such a civilization would continue broadcasting or existing before going quiet, whether through collapse, self-destruction, or simply moving on to a form of communication we would not recognize as a signal at all. The problem, the part that makes the Drake equation more of a thinking tool than a working calculator, is that most of those numbers are essentially guesses, and small changes in the guesses produce wildly different final answers. When Drake first presented it, estimates for the number of communicating civilizations in our galaxy alone ranged anywhere from 1,000 to 100 million. That is not a rounding error. That is the difference between a galaxy that is nearly empty and a galaxy that is teeming with company we simply have not found yet. And that uncertainty tends to concentrate almost entirely in one single variable: the length of time a technological civilization tends to survive. If most civilizations wipe themselves out within a century or two of developing the kind of technology capable of destroying themselves, nuclear weapons, engineered pathogens, runaway artificial intelligence, environmental collapse, then the galaxy could easily be full of ancient graveyards and almost nothing currently broadcasting. If even a small percentage managed to survive that dangerous adolescent phase, the number of civilizations that should exist right now climbs into the millions. that uncomfortable idea has a name too, and it is one of the most unsettling explanations ever proposed for the silence. Scientists call it the Great Filter, the notion that somewhere along the long chain of steps between lifeless chemistry and a civilization capable of colonizing other star systems, there exists some barrier so difficult to pass that almost nothing manages to get through it. And here is the genuinely disturbing part of that idea, the part that tends to make people go quiet when they first hear it. Explained properly, nobody knows whether that filter sits behind us or ahead of us. If the filter is behind us, if the near impossible step was something like the origin of life itself, or the leap from simple single-celled organisms to complex ones, or the rare accident of intelligence evolving at all, then humanity has already cleared the hardest part, and our future, cosmically speaking, might be bright and mostly unobstructed. But if the filter is still ahead of us, if it is something like the invention of nuclear weapons, or biotechnology capable of engineering a civilization-ending pathogen, or an artificial intelligence system that outgrows its creators before anyone fully understands what they built, then the silence we hear across the galaxy is not comforting at all. It might be a warning. Every civilization that reaches roughly our level of technological development might simply not make it much further, and the quiet sky above us might be less an absence of neighbors and more a monument to everyone who came before and did not survive their own cleverness. If a question like that is the kind of thing you find yourself thinking about long after you close a video, it is worth sticking around for the rest of this one, because the picture only gets stranger from here, and there is a genuinely useful framework worth understanding before we go any further. In the 1960s, a Soviet astronomer named Nikolai Kardashev proposed a way to classify hypothetical civilizations, not by their culture or their politics, but by the sheer scale of energy they had learned to harness. A Type 1 civilization, in his framework, would be one that had learned to capture and use essentially all the energy available on its home planet. A Type 2 civilization would have moved beyond that, capturing the entire energy output of its home star, potentially through a theoretical megastructure known as a Dyson sphere, a shell or swarm of collectors built to encircle a sun and use nearly all of its light rather than letting the overwhelming majority of it simply radiate away uselessly into empty space. A Type 3 civilization would have scaled up further still, commanding the energy output of an entire galaxy. By that measurement, humanity does not even fully qualify as Type 1 yet, still relying on a patchwork of fossil fuels, nuclear reactors, and renewable sources that together capture only a small fraction of the energy theoretically available on our own planet, let alone our star. The scale gap between where we currently sit and where a Type 2 or Type 3 civilization would sit is not a difference of degree. It is a difference so vast that a civilization at that level manipulating energy on a stellar or galactic scale should, in principle, be almost impossible to miss, showing up in astronomical surveys as unusual heat signatures, stars that dim in strange artificial patterns, or energy usage that simply does not match anything nature produces on its own. And that is precisely why the total absence of any confirmed detection, after decades of increasingly sensitive searching, carries so much weight in this conversation. It is not just that we have not heard a deliberate radio greeting. It is that we have not spotted the accidental fingerprints that an energy-hungry civilization at real cosmic scale would almost certainly leave behind, whether it meant to or not. Sabine Hossenfelder approaches this entire subject with the same instincts that made her a respected and occasionally controversial voice inside academic physics, a deep discomfort with elegant, exciting ideas that outrun the actual evidence supporting them. Her scientific reputation was built criticizing exactly this failure mode inside her own field, arguing in her writing that too much of modern theoretical physics chases mathematically beautiful concepts, extra dimensions, supersymmetry, certain multiverse theories, because they feel satisfying, not because there is experimental data forcing anyone toward those conclusions. When she turns that same skepticism toward UFOs, the pattern she describes is strikingly familiar. A strange reading appears on a sensor. It gets multiplied online into elaborate explanations involving craft that defy the laws of physics, technology thousands of years beyond our own, deliberate cover-ups reaching the highest levels of government. And somewhere in that chain, the boring, mundane explanations that actually account for the overwhelming majority of unexplained sightings get quietly left behind, not because they were disproven, but because they are simply less exciting to talk about. Weather balloons, flocks of birds catching light at unusual angles, sensor glare and lens artifacts inside expensive military optics that were never actually designed or calibrated for the kind of long-range identification people now expect from them, foreign or domestic drones testing the edges of restricted airspace, distant aircraft whose apparent motion gets warped by the geometry of how a camera or a human eye tracks something moving against a nearly featureless sky, sometimes creating the illusion of impossible acceleration or a sudden right-angle turn that never actually happened in three-dimensional space. None of that is a dismissal. It is simply an acknowledgement that the human perceptual and technical systems used to observe the sky are far less reliable than most people assume, especially at the edges of their operating range, and that unexplained does not automatically mean unexplainable, let alone extraterrestrial. That distinction between something merely being unidentified and something requiring an exotic explanation sits at the center of how the actual scientific and military investigation into this subject has unfolded over the last several years, and the story of how that investigation became public is genuinely worth walking through in detail because it explains why this conversation looks so different today than it did even a decade ago. For most of the 20th century, the United States government's official posture toward reports of unusual aerial activity was investigated primarily through a Cold War-era Air Force program called Project Blue Book, which ran from 1952 until it was shut down in 1969, having examined more than 12,000 reported sightings, and concluding that the vast majority had mundane, identifiable explanations, with a small residual percentage left formally unresolved due to insufficient data. That was for decades treated as the final word. The subject retreated into the cultural fringe, associated more with tabloid headlines and conspiracy forums than with serious defense or scientific institutions. That changed abruptly in December of 2017 when the New York Times published an investigation revealing the existence of a previously secret Pentagon program that had, for years, quietly studied reports of unidentified aerial phenomena, accompanied by released cockpit video from Navy fighter jets showing objects moving in ways their pilots could not immediately explain, tracked simultaneously by radar, infrared cameras, and direct visual observation from multiple aircraft. The most famous of these became known publicly as the Tic Tac encounter, filmed off the coast of California in 2004 by pilots flying from the aircraft carrier USS Nimitz, showing an elongated white object that appeared, according to the pilot's own accounts and the accompanying sensor data, to descend from roughly 80,000 feet to just above the ocean surface in a matter of seconds, without any visible means of propulsion, exhaust, or aerodynamic control surfaces, before accelerating away faster than their own advanced fighter jet could follow. That single case, and a handful of others released alongside it, changed the tone of the public conversation almost overnight, because the source was no longer an anonymous witness describing lights in the sky from a backyard. It was multiple trained combat pilots, backed by radar and infrared confirmation, filing official reports through military channels. If this is the kind of story where the real, sourced version turns out to be stranger than the exaggerated one, that is generally a good sign you are watching the right kind of channel. And following along for the rest of this breakdown is worth it, because the institutional response that followed is where the story gets genuinely surprising. Congress responded with genuine institutional weight rather than dismissal. In 2022, following a provision in that year's National Defense Authorization Act, the Pentagon formally established the All-Domain Anomaly Resolution Office, generally shortened to AARO, tasked specifically with detecting, tracking, and if possible, resolving reports of what the government now officially calls unidentified anomalous phenomena, deliberately using that broader, more careful term instead of the older and more culturally loaded phrase unidentified flying object. The office was designed to collect reports from across every domain, air, sea, land, space, and even underwater, reflecting the fact that a meaningful number of naval reports describe objects appearing to move between water and air with no apparent transition or splash. Congress held a series of public hearings on the subject in 2023, and the most explosive moment came from a former intelligence officer named David Grush, who testified under oath that the United States government was secretly in possession of recovered non-human craft and had been conducting a decades-long program to reverse engineer that technology while deliberately concealing its existence from Congress and the public. Those were extraordinary claims made under formal oath before lawmakers, and they deserve to be stated plainly rather than dismissed reflexively, because sworn testimony carries real legal weight. They also, as of today, remain entirely uncorroborated by any physical evidence, document, or independent witness that has been made public, and ARO's own subsequent multi-year historical review, which examined UAP-related claims and programs going back to 1945, stated directly that it found no evidence to substantiate the existence of any secret reverse engineering program or any recovered craft of non-human origin. The pace of official disclosure accelerated sharply in 2026, and this is where the story stops being purely historical and becomes something happening in real time. On February 19th of this year, President Trump directed the Secretary of Defense and other relevant federal agencies to begin identifying and releasing government files related to unidentified anomalous phenomena, framing it publicly as a transparency initiative. Defense Secretary Pete Hegseth confirmed the Pentagon was actively working to implement that directive, and on May 8, 2026, the Department of War, the renamed successor to the Department of Defense, announced the first formal release of previously unseen UAP case files, spanning archives from multiple federal agencies. Among the released material was an enlarged section of an archival Apollo 17 photograph from the lunar surface, showing 3 unexplained points of light above the terrain, alongside modern military-sourced imagery, including footage from United States Indo-Pacific Command showing a football-shaped object reported near Japan. It is worth being precise about what officials said accompanying that release, because the headline framing and the actual substance diverge in an important way. Despite reviewing decades of accumulated historical case files, Arrow's own conclusion, restated again at the time of this release, was that none of their reviews had found anything leading them to conclude that any UAP or UFO reports were extraterrestrial in origin. Transparency, in this case, did not mean confirmation. It meant opening the archive and letting the public see for themselves that the vast majority of what is inside it looks far less like alien technology and far more like a messy, decades-long accumulation of misidentified balloons, drones, sensor artifacts, and a stubborn residue of cases that genuinely remain unexplained simply because the original data collected on them was too limited to draw any firm conclusion at all. That residue of genuinely unresolved cases is smaller than popular coverage often implies, but it is not zero, and the most recent government reporting is refreshingly candid about that fact, rather than sweeping it under the rug. Arrow's fiscal year 2025 Consolidated Annual Report, released this past summer, disclosed that the office continues to receive reports it simply cannot close, including 2 specific incidents in the most recent reporting period, describing electronic or avionic interference near operational military aircraft that investigators have not yet determined were, or were not, attributable to the anomalous objects observed nearby. In July, Defense Scoop reported that the Pentagon was actively investigating a mysterious UAP event reported by the Navy off the coast of Virginia, with officials writing plainly in the released document that no technical data accompanied the original reports, and that if the underlying phenomena were ever validated, they could represent what the report called a currently unmitigated threat vector. That phrasing matters because it captures the actual working posture of the people paid to take this seriously at an institutional level, and it is neither the breathless certainty of true believers convinced aliens are already here, nor the reflexive eye roll of someone assuming every report must be a weather balloon. It is something closer to disciplined uncertainty, a lack of timely and actionable sensor data, continuing to constrain the office's ability to resolve a meaningful fraction of what gets reported to it year after year, without that unresolved status being treated as secret proof of anything in particular. This is precisely the gap where Sabine Hossenfelder's specific scientific framing becomes genuinely useful, because it offers a way to hold 2 things true at the same time that popular discourse usually forces into opposition. The first true thing is that dismissing every single UAP report as a hoax or a hallucination is intellectually lazy and does not actually match the available evidence, since a meaningful number of these reports come from trained military observers using calibrated instruments, and a real, if small, percentage genuinely resist conventional explanation even after serious investigation. The second true thing, existing comfortably alongside the first, is that unexplained is a very different category from extraterrestrial, and jumping directly from one to the other skips over an enormous number of far more mundane possibilities that happen to be far less exciting to talk about. Advanced classified aircraft and sensor technology developed by the United States or rival nations like China or Russia deliberately kept secret precisely because revealing their existence would compromise their military value, would produce exactly the kind of performance characteristics that look impossible to an observer who has no security clearance and no idea what they are actually looking at. Sensor and optical artifacts inside genuinely cutting-edge infrared and radar systems, effects that engineers are still discovering as those systems get pushed into unfamiliar operating conditions, can produce readings that look like objects violating the laws of physics without any actual object doing anything unusual at all. And the sheer psychological unreliability of human perception under stress, at high speed, at night, staring at instruments never designed for identification in the first place, accounts for a surprisingly large share of the residual mystery once investigators are finally able to go back and cross-check the original reports against better data. None of that requires assuming anyone involved is lying. It only requires accepting that the universe of possible mundane explanations is far larger and far less interesting than the universe of possible alien ones, and that basic probability, not any particular agenda, should push a careful thinker toward the boring explanation first, every single time, until the evidence genuinely leaves no other option. Where this conversation becomes genuinely fascinating, rather than merely skeptical, is in how it reconnects directly back to the Fermi Paradox itself. Because the 2 questions, are there unidentified objects in our sky, and is there intelligent life anywhere else in the universe, are actually almost completely separate scientific problems that popular culture has spent decades accidentally fusing into one. You can believe with total confidence that the universe is teeming with intelligent life scattered across countless star systems, a position plenty of serious astronomers genuinely hold, while also believing there is essentially no credible evidence that any of that life has ever physically visited Earth, because the distances involved are so staggeringly vast that even a civilization millions of years more advanced than our own would face genuine physical constraints on interstellar travel that no amount of advanced engineering obviously eliminates. The nearest star system beyond our own sun, Alpha Centauri, sits a little over 4 light-years away, meaning even light itself, the fastest thing physics allows anything to travel, takes more than 4 years to make that one-way trip. Scale that distance across the roughly 100,000 light-year width of our galaxy, and the idea of a civilization casually popping over to buzz a few Navy destroyers off the California coast starts to look less like advanced technology and more like a fundamental misunderstanding of just how empty an enormous space actually is. That does not make interstellar travel physically impossible. Serious physicists continue publishing genuine research into concepts like generation ships, suspended animation, or exotic propulsion methods that remain purely theoretical today. It simply means that if visitors were showing up on Earth with any regularity, the engineering and energy requirements to make that trip in the first place would represent an achievement so extraordinary that the crude, seemingly limited maneuvering described in most UAP reports, darting around at relatively modest altitudes above a random ocean, sits oddly alongside a civilization supposedly capable of crossing interstellar distances that dwarf anything humanity can currently even attempt. That mismatch feeds directly into some of the newer and stranger academic attempts to resolve the Fermi Paradox, several of which Hossenfelder has covered on her own science channel with the same careful, evidence-first tone she brings to the UAP question. One recent line of research she discussed examined the paradox not by asking how likely life is to form, but by modeling how civilizations capable of sending detectable signals across space would actually tend to develop and behave over cosmic timescales, and the findings were, in her own description, quite bleak. Rather than assuming every advanced civilization eventually broadcasts loudly and indefinitely, the model suggested that the detectable signal-producing phase of any civilization's existence might genuinely be extremely brief on a cosmic timescale, a narrow window measured in centuries rather than millions of years, after which a civilization either destroys itself or simply evolves past the need for the kind of energy-leaking, broadly detectable electromagnetic communication that current search efforts are actually built to look for. Humanity's own so-called radio age, the roughly 100-year stretch during which our planet has been leaking detectable radio and television signals out into space, might already represent close to the entire useful window during which an outside observer could have noticed us at all, a sobering thought once you actually sit with it. And since it implies the silence we hear might not mean nobody's out there. It might simply mean almost everybody's brief, noisy adolescent phase happens to be badly out of sync in time with everyone else's, two civilizations passing through their loud years millions of years apart, never once overlapping long enough to actually hear each other. Other recent papers have pushed in an even stranger technical direction, proposing that certain forms of interstellar communication might not even look like the kind of signal our current search programs are built to detect at all. One paper specifically suggesting that a sufficiently advanced civilization might rely on quantum communication methods rather than conventional radio waves, a technology that would be functionally invisible to instruments like the ones used by SETI, the decades-long search for extraterrestrial intelligence, which has spent generations scanning the sky for exactly the kind of electromagnetic chatter that a truly advanced society might have abandoned as primitive long ago, in the same way a modern military would never rely on smoke signals. Separately, newer 2026 research out of the SETI Institute proposed something almost mundane by comparison, but potentially just as significant, suggesting that ordinary stellar activity, plasma turbulence generated by the solar wind, and magnetic behavior of stars themselves could physically broaden and smear out narrowband radio signals traveling across interstellar distances, pushing genuine transmissions below the sensitivity threshold that current detection equipment is capable of picking up, meaning some real signals could theoretically already be washing quietly past Earth, present in the data, simply too faint and too smeared to register as anything other than background noise. Taken together, these newer lines of research do not answer the Fermi Paradox so much as they multiply the number of genuinely plausible reasons the silence might exist without requiring either total cosmic loneliness or secret alien cover-up, and that expanding menu of mundane, physically grounded explanations is, in its own understated way, exactly the kind of finding that a scientist built around demanding rigor before excitement finds far more compelling than any single dramatic breakthrough claim. There is one more idea worth sitting with before we get to where all of this actually leaves us. because it flips the entire question upside down in a way that a lot of people find genuinely unsettling the first time they hear it. Rather than asking why we have not found any evidence of other civilizations, a line of research sometimes referred to as the grabby aliens model asks a different question entirely. What would the universe look like if most civilizations that ever arise are still simply too young or too far away in both space and time for their expansion to have reached us yet? Under this model, civilizations that become capable of expanding across interstellar space tend to expand fast and keep expanding, becoming impossible to miss once they arrive somewhere, loud in exactly the sense the earlier stellar engineering argument described. If that is true, then the reason we see nothing yet is not necessarily that intelligent life is rare. It may simply be that the universe is still relatively young in the specific narrow window when the first such expanding civilizations are only now beginning to appear, and humanity, by pure accident of timing, happens to be looking up at the sky during one of the last remaining quiet chapters before that changes permanently. It is a strange, almost vertigo-inducing thought that the silence might not be a permanent feature of the universe at all, but a temporary one, and that the generations who eventually break it might not be so different in age from people alive today. If a thought like that is the kind of thing that changes how you look at the night sky, that is exactly the kind of shift worth sharing with someone else who would appreciate it, and dropping your own take on which explanation feels most likely. The great filter, the grabby aliens model, or simple cosmic loneliness, is the kind of conversation that tends to be far more interesting in the comments than it ever is alone. It is worth pausing here to say plainly what remains genuinely unresolved, because pretending otherwise in either direction would be dishonest. Nobody currently has definitive proof that intelligent extraterrestrial life exists anywhere else in the universe. Nobody currently has definitive proof that it does not. The search continues on multiple fronts simultaneously. Radio telescope surveys scanning nearby star systems for artificial signals, optical searches looking for laser pulses that natural astrophysical processes are extremely unlikely to produce, and a newer, rapidly growing field called technosignature research, which looks for indirect physical evidence of advanced engineering, unusual heat signatures that might indicate a Dyson sphere partially capturing a star's energy output, atmospheric chemical signatures on distant exoplanets that would be extremely difficult to explain without biological or industrial activity, or patterns of stellar dimming that do not match any known natural cause. None of these searches has yet produced a confirmed detection. Every one of them continues expanding in scope and sensitivity as telescope technology improves, meaning the coming decade genuinely represents one of the most promising windows humanity has ever had to either find something conclusive or meaningfully narrow down where the answer is not hiding. What makes Hossenfelder's specific approach to this entire subject worth paying attention to, more than any single conclusion she reaches, is the discipline underneath it, an insistence on separating what the evidence actually supports from what would simply feel satisfying to believe, applied with exactly the same rigor whether the subject is a glowing object over a Navy carrier or a fashionable theory circulating inside elite physics departments. That discipline runs directly against the grain of how this topic usually gets discussed publicly, where it tends to collapse into two exhausted camps shouting past each other, one insisting the truth is already known and being actively hidden, the other insisting the entire subject is beneath serious consideration and unworthy of a real scientist's time. The actual state of the evidence sits, uncomfortably, in the space between those two positions, closer to genuine, disciplined not knowing than to either camp's certainty, and that in-between space is exactly where real science tends to live, whether the subject is a strange radar return over the Pacific Ocean or the deep, patient silence still hanging over an entire galaxy full of stars that, as far as anyone can currently prove, are simply waiting. The next several years are likely to bring more of exactly this pattern rather than a single dramatic resolution. More declassified files that turn out to contain more balloons and drones than spacecraft, more genuinely unresolved sensor readings that a small percentage of dedicated engineers will keep quietly chasing without a definitive answer, and more careful, incremental research chipping away at the enormous space of possible explanations for why the universe looks so empty despite every reasonable calculation suggesting it should not be. If any of this is the kind of question that keeps you looking up at the night sky a little longer than you used to, it is worth remembering that the honest scientific answer right now is not a comforting yes, and it is not a dismissive no. It is a patient ongoing search, conducted by people who have learned, sometimes the hard way, that the universe rarely hands over its biggest secrets easily, and that the difference between a mystery and a discovery is usually nothing more than better data, more time, and the discipline to keep asking the question honestly, long after the easy, exciting answer has already stopped being enough.